Hey students, welcome to unit number 4. This is lesson 4.0 and we are going to be talking about the area of rectangles. Now this is a review lesson. You should already know how to find the area of rectangles, but we are going to review and this review will prepare you for further lessons that we're going to be looking at other types of shapes. So right here we have these rectangles, and some of the things that you should recognize about a rectangle is that, of course, it has 4 sides, and that you can also see that this side right here is equal to this side, and this side is equal to this side. One of the biggest misconceptions that I see with students is that if it gives you this side and it gives you this side, and then I say, what is this side over here? Well, a lot of students can't or don't know, okay, because this is 3, this is also 3. And because this is 2, this is also 2. So that's something that you should know going into this lesson, that if you have a rectangle, that there's 4 sides and that the 2 opposite sides are going to be equal to one another. The other thing that you should be very familiar with is that you should know that there's a formula to find the area of a rectangle, and that is area equals length times width, and sometimes that we also call it the base times the height. Now it doesn't matter which one of these that you use, base times height or length times width, it's the same thing. So again, if we're looking at the base of a figure, it's the bottom or the top because they're equal, and the height is this. If we're looking at the length and the width, the length is how long it is, and the width is how, wide it is. So it doesn't matter what you call it, it's the same formula. It's just a labeling issue. You will find that when we go into triangles, we will be using base times height. I tend to prefer to use base times height over length times width, but I know that in elementary school, a lot of teachers teach length times width. So I'm just making that designation right now that they are the same thing. So let's practice this just a little bit. If I was to say that this is 11 and this is 6, so I'm using my formula, area equals base times height. So my base is 11, my height is 6, so my area is going to equal 66. And we should talk about this too. If it's in inches, it's very important that we put inches squared. If it's in centimeters, we put centimeters squared. It just, those units of measurement are really, really important when we're talking about, area and length and things like that. Those labels matter. Okay, let's practice one more of those really quick. Let's say that I have this, and this time I'm going to use the length times the width just to show you it doesn't change anything. So I'm going to take this little rectangle and scoot it right there. I know that this one is 12.5, and that the height of this one, let's say it's 20, and we're going to call it centimeters. Now, if I want to find the area, I'm going to go area equals length times width. The length is 12.5, and my width is 20. And if I multiply those together, it's going to give me my area. And yes, from this point forward, you can use a calculator. So if you wanted to get your calculator out, you could follow along with me. I'm going to go 12.5 times 20, and it gives me 250. So I know that my answer is 250 centimeters squared. And a lot of students have asked me, well, why is it squared? Why am I squaring it? Well, how many measurements did you multiply together to get this product right here? Well, I measured 1, 2. So there's 2 different things. And what it's saying is if this measurements were right, that we would have 20 20 rows going this way. And I'm not going to draw all of them, but just get the idea in your head. And that we would have 12 and a half going this way. And if we added all those little tiny squares up, notice I said squares, there would be 250 squares in that area. So that's where all of those kind of come together is, okay, well, we're squaring it because there's two different things, and those squares, well, that's why we call it squared. When we have something squared is because it makes squares when we fill up that area. Okay? All right, let's move on to your bell work. Hey, students, we're on your bell work for today. This first question here is finding the area of triangles. Now, when we're finding the area of triangles, this is actually going to help you for a lesson that we have in 2 days from now. But let's go over how to find the area of a triangle. Some of you may already know. We're going to use this formula. Area equals base times height divided by 2. Now, let me explain something to you. This formula that we introduced to you yesterday when we talked about rectangles, area equals base times height or length times width, that was how we found a rectangle. So how does this formula right here differ from this formula? We added something to it. We added divided by 2. So I want you to think about this for a minute. If I said the area equals base times height, and that gives me a rectangle or a quadrilateral, something that has 4 sides, and then I divided it by 2, and it gives me the triangle now, what is the relationship between a triangle and a rectangle? Well, we divide by 2. That means that the triangle is always half of a rectangle. Okay? And if you think about that, that's really true. On this one, you can see that if I go like this, it makes a rectangle. Or if we wanted to copy this exact triangle here, it makes a quadrilateral. And a quadrilateral and a triangle and a rectangle are very similar. It's just that the sides are kind of slanted. But we use the same formula. So let's try this out now. I'm going to use this formula to find the area of this triangle. And all we have to do is know the base and the height. So my base is 7. My height is 4. I'm going to divide it by 2. 7 times 4 is 28. Divided by 2 equals 14. Now, something else I want to point out to you. It's very important to list that unit of measurement. And because it's area, it's always squared. And you might be asking yourself, well, why is it squared? Well, because of what I talked about on the slide previous to this. We multiplied 2 things together, and that gives us, and that's why it's squared. There's 2 dimensions that we're looking at here. All right, let's take a look at this next triangle. We're going to follow that same formula that we've been using. We are going to do area equals base times height divided by 2. My base on this one is 8. My height is 3. Now, look at this. This little guy right here, this leg, this is not the height of the triangle. Okay? It's a side length, but it is not the height. The height is it has the relationship with the base of a 90 degrees, and that's what that little square right there means, 90 degrees. It has to have that relationship of a 90 degree to be a true height of a triangle. That's why you can see it extends out here to the end of that triangle, and it makes a 90 degree angle. That's the height. So we're going to go, base is 8, height is 3. We're going to divide it by 2. 3 times 8 is 24. 24 divided by 2 is 12. So we have 12 millimeters squared. That is our answer for that one. 14 meters squared is the first one. Let's move on to number 2. Which expression is equal to 3a plus 3b plus 3c? Think about it for a minute. Which one of those is multiplying which one of these can we use to get to that? So I'm going to just show you here. 3 times A is 3A. 3 times B is 3B. And 3 times C is 3C. Now, what property did we use to find that equivalent expression? If you're thinking in your head right now, we use distribution, you're absolutely correct. Now, on this next one, it says, use the distributive property to write an equivalent expression. Now, I'm going to help you out with this one, too. I'm going to go 3 times 2x. Now, why did I start there? Because parentheses, order of operations, that's the first thing that I do. So 6x, 3 times 4y is 12y, and then I bring that x down. Now, we can go, oh, you know what? I have an x, and I have an x, and then I also have this y right here. So can anything be combined? Of course. 7x plus 12y is our answer. And you've seen a couple of problems like that as we were doing the last unit. So hopefully that's not something that you're like, whoa, I don't get that. All right, let's move into our lesson for the day. All right, as I said before, this is a review, and we're just reviewing the how to find the area of rectangles. What I would like you to do, however, is I would like you to make kind of a cheat sheet here. You can use this for the activity that we're going to be using. I would like you right here at the top of your page to write area equals length times width, or, and I want you to put a line right here, area equals base times height. I don't care which one you use. Whichever one you feel comfortable with, that's the one I want you to use. Okay, so let's try this out. Let's look at this number 1. We have a square right there. And we know that all of those corners are 90-degree angles. We also know that a square has sides that are all equal, 12, 12, 12. And we better put inches on there too, because that's important. Now, if I wanted to find the area for this one, I'm just going to use my formula. Area equals length times width. Okay, so now, do I have the length and the width? I do. I have 12 times 12. And you can use a calculator if you don't know what 12 times 12 is. Area equals 144 inches squared. Yes, that is really important to do, to put that unit of measurement squared. Okay, not too bad, right? Should be a review. So let's do that again. Let's start right here. I always like to list what I do know about my shape. In this rectangle, I know that that's 9, and I know that this is 5 feet also. Because sometimes it asks you to find the perimeter and the area. So if you need to do that, that comes in handy. All right. So using our formula, area equals, and I use length times width. I'm going to use base times height this time just to try it out. Base times height. Do I have the base? Yes, 9. Do I have the height? Yes, 5. So when I multiply those together, I get 45. And my area now equals 45. And it's very important to put 45 feet squared. And guys, another point I want to make right here, that unit of measurement, if I needed a piece of board from Home Depot and I went to the store and I said, I need a board that's 45. Well, the worker would say, 45 what? And you better understand that 45 feet of board is different than 45 feet squared. If I had 45 feet of board, that's a board that's that long, 45 feet long, right? Now, if I asked for a 45 foot squared board, well, we would have a piece of board that would have what looks like this. So can you see the difference there? That squared makes a huge difference in what you're looking at. It's 2 dimensions. We measured 2 dimensions, and that's why it's squared. All right, let's move on to number 3. Actually, I want you to try number 3 on your own. I think that you guys can probably do the rest of this, especially with a calculator. I want you to try those 4 problems on your own. I am going to pause this, and then I'll find out what the answers are, and then we can see if you got the same answers that I get. All right, so take a look at those 4 answers right there. That is what you should have got. Guys, this should be a review, like I've said a couple times before. Hopefully this is not something that's new to you, that you're familiar with it. If you're having a difficult time comprehending this and understanding what we're really doing, please raise your hand and ask your teacher for some help, or contact them and ask for help. All right, guys, tomorrow we'll be looking at how to find the area of quadrilaterals, which isn't a very far stretch from what we're doing here. But we'll see you tomorrow. Bye.